All right, so here we are back again. Now we're in class 2, exercise 4. Class 2, exercise 4, and I put my camera on the bottom right so that you can see this better. Yay! All right, so we're going to continue playing with hashes, but we're going to use these two concepts, HMAC, message authentication code, so hash-based message authentication code, HMAC, and PBKDF, so password-based key derivation function 2. And so these two methods make it a password actually much harder to guess, not only by putting not only by hashing and adding the salt, but also repeating the process a number of times, called the work factor here, which make it a lot harder to guess. So let's run this. It's going to be pretty straightforward. So we're going to create pretty much like we did last time. We're going to create a new file, and we're going to call it that. And here we're going to put this HTML. It's basically a very simple web form that does a post. Again, it's going to complain about localhost. I don't want that. Remember, I'm going to fix that right now so I don't have surprises. And then we're going to go down and create this other file called the processor file. New file, new file. Yes. And in the processor file, we have a lot more code to drop in, which is all the way from here, all the way to here. So then we're going to save that, and we save that. So now let's see if we can operate. We go into our, whoa, that's not what I want. We need a file name here. Let's figure out what the file name should be. Let's go back in our exercise. We're going to use this password-based key derivation function, right? Key derivation function, password-based. Let's put it there. Okay, so we are now going to take another one called hot dog and hash that puppy. So now we're running with 100 times, with 101 times, and again with 100 iterations. So notice that the number of iterations does not actually change the hash. It still ends in DB36A, DB36A, but if we do it one extra time, we end up in a whole different hash. I thought it should be useful. I'd like to point out that your Linux Kali does the exact same sort of thing. If you look at Etsy password, this is where the passwords, well, should be stored, but they're not actually here. So these are all the users. The password's actually stored in more Etsy shadow. And I cannot because I have to actually say sudo. So if I look at Etsy shadow, notice that my Kali, the password is not actually stored here, but it's actually this particular string is my password. So, and it actually doesn't use SHA-256. It uses a different, it uses I think SHA-512, and there's a different number of work factors that it does and the salt and all that. So I'm not going to be able to reproduce my password, but essentially it does exactly what this code does here. So yes, so we're looking at this code, right? The number of bits 80, 100 iterations or 101 iterations. It creates a salt again, or you get some number, it creates a salt because base64 encodes it to make sure it's text. And then it runs the 3 iterations that we saw here. 1 time hash by taking 3 parameters, the input, the salt, and the iterations. And again, the same thing, input, salt, and iterations, but the 101 instead of 102. And then we run it again, like the original one, to see that we get the same thing. That's it. And that's the end of exercise number 4. Thank you. I'll be back for 5.